So in this series of Snap Circuits videos, we're looking at Project 377, the Space War Alarm by SCR, and going all the way to Project 408, the 5th Oscillator Sound project. So with Project 377, the Space War Alarm by SCR, there it is in the book, and here it is on the board. Now we're not using a jumper wire like it has in the diagram there. I'm just using a number 4 snap here. But we got a 3-volt supply, mainly focused with our Space War IC here with our speaker for the output, and then the control input is being done via our SCR, and then we have our 5.1K resistor going to the gate of the SCR control. And by having the 4 snap here, we're actually shunting the power through our resistor to ground in this way, so the SCR never triggers, nor does it ever get power through our Space War IC. Now of course if we break the link, the SCR activates, allowing current to flow through into our Space War IC, and then it generates the sound. And if I put the 4 snap wire back, it stops because we divert enough current away from the SCR that it can no longer run the Space War IC. So that's how Project 377 works now. Project 378 is the light Space War alarm. So the only modification we're doing with that is taking our resistor out here. I can do this without taking too much stuff out, and replacing it with our photoresistor, so now we can control the input to our SCR with our photoresistor. There. And so we'll plug in, and we'll start with it covered up. So by keeping our photoresistor covered up, we're not allowing enough current to reach the gate of the SCR there. Now what's funny is I don't know if the camera's picking up, but I can hear the Space War IC ever so slightly trying to put sound out. So there's actually a lot of resistance there. But if I start letting some light in, the Space War IC starts up. And by changing my hand position, I can actually get it to kind of go down in amplitude or even slow down. Which is kind of interesting. So that's project number 378. So now we're going to move on to project 379, which is Alarm by SCR. Here at project 379, Alarm by SCR. There it is in the book, and here it is on the board, and it looks very similar to project 377, wherever we're using the Space War IC, but now we're using the Alarm IC instead. So it's very much the same setup with the 3 volts and their speaker on the output of our Alarm IC, with our Alarm IC being fed via the SCR, but we're using the 10,000 ohm resistor this time instead of the 5.1K. Again, same setup with our 4 snap, kind of interrupting the connection to bring it to ground, and of course we take it away, we get a siren playing out of the speaker, because again our SCR is providing a path. If I reconnect it, well, it shunts the power away, and so the Alarm IC no longer runs. So that's how Project 379 is. Now Project 380 is Light and Alarm IC. So again, like Project 378 with the Space War IC, the photoresistor is going to go in place of our resistor there, which will allow us to control the Alarm IC through the SCR using our photoresistor. So pump it in there, put it on, and I'll cover up the photoresistor. And if we start letting some light in, because right now again we're not allowing enough current to reach the gate to activate our SCR. Let the light in, now the Alarm IC can activate. But you see how this time it doesn't shut off. It doesn't have the limitations that the Space 4 IC did. So that's how Project 380 works. Now we're going to move on to Project 381, which is the delay light. So here we are with project number 381, the delay light. There it is in the book, and here it is on the board. And here we're making use of 6 volts, and I'm not using the battery boxes, so I've just got a 3-snap going to the switch here. Otherwise you'd have the battery boxes here and the switch in the middle. But anyway, the circuit still works as normal. So we're using 6 volts, and we have our SCR with our 6-volt lamp across it connected to ground, and the SCR is being triggered by our NPN transistor. And our NPN transistor is being triggered over here by the combination of our press switch, but also our 100 microfarad capacitor. So our NPN transistor is going to wait until this capacitor is sufficiently charged before it will allow current to start flowing through here, which will then of course trigger our SCR, allowing our lamp to come on and stay on regardless of the state afterwards. So we turn the slide switch on. Obviously the light is off because there is no trigger on our SCR to allow any current to pass through here. So we're going to press the press switch, and this will allow charge to go into our capacitor. And once it gets enough charge, this should turn on, which then will turn on our SCR. So we press the press switch. And after a couple of seconds, our SCR turns on and our 6-volt light illuminates. And after I release the press switch, again, the capacitor will discharge, so our NPN transistor at this point is no longer on, but because of the way the SCR works, well, again, once it's been triggered, it always stays on until we turn off the power. So we turn off the power, turn it back on, the SCR is reset, our lamp is back off. We press our press switch to charge our capacitor back up. And after a few seconds, our lamp illuminates again. So that is how project number 381 works. Now we're going to look at project 382, which is the delay fan. So for this, we're obviously going to use our motor, and we're going to take our lamp and move it down here where this 3-snap is. So take that off. We'll put this here. Then we'll take our motor and put our motor up here instead. And now we'll do the same process. Turn the slide switch on. Our motor doesn't spin, our light doesn't light, but we'll press our press switch down. And after a few seconds, again, after it charges the capacitor up enough, our NPN transistor turns on, allowing our SCR to trigger, and now both our motor turns on and spins, and we get a little bit of illumination out of our 6-volt lamp there. And again, once you turn the power off and back on, it resets the SCR, so we'd have to press down the button again. And again, after a few seconds, it comes back on. So that is project number 382. So project 383 is delay fan 2. So what we're going to do with that is simply change out our capacitor here. So instead of the 100 microfarad capacitor, we are replacing it with the 470. So this means we're going to have higher capacitance in the circuit than what we did with the 100. So what do you think is going to happen when we use this bigger capacitor? So we turn the circuit on. Again, the SCR is not triggered, so nothing's going to happen. Press down our press switch. And we wait. And wait. And now the motor and the lamp come on. So you notice that when we went to a bigger capacitor, this one is almost 4 to 5 times the capacitance of our 100 here. It took quite a bit more time for that capacitor to charge up sufficiently to trigger our NPN transistor and thus our SCR. So with a smaller capacitor, it takes just a few seconds to trigger our SCR there, but when we went to the bigger capacitor there, it took quite a bit more time for our SCR to trigger because it took more energy to charge up this capacitor. So do it again. And we just hold down our press switch, charging that 470 microfarad capacitor up, and then when it's sufficient, we can trigger the SCR. So that is project number 383. So now we're going to move on to project 384, which is the recording LED indicator. So here we are with project number 384, the recording LED indicator. That it is in the book, and here it is on the board. And so here we've got our 6-volt setup, and again I'm just using a 5-snap to accommodate for the lack of the extra battery box using the AC adapter here. But our central point here is our recording IC, and it feeds its output to the base of our NPN transistor, which has our speaker for output, and then it's got the 6-volt lamp to help limit the current, although we'll still see this light up a little bit. Then we have our regular D3 diode coming in for the recording IC, which then goes to our D1 red LED, which you see is lit up here, going through our 100 ohm resistor. That comes down through our green D2 LED here, which you also see lit, and then it goes over to our microphone, which provides our voice input to the recording IC. And then we have our slide switch, which allows us to activate the recording function of the IC, and then we have our press switch for the playback function. So right now, both LEDs are on, so this indicates we have power, and this indicates that the recording IC is not in its recording state. So if we turn the slide switch on, we get our 1 beep, the green LED goes out, and then we get our 2 beeps, and our green LED comes back on to tell us that it's no longer in its recording mode. So then we do a quick recording here. I'll just blow into the microphone on it. So that gives us a quick 2-pulse blow on there, and we'll actually see that effect on our 6-volt lamp here. If the camera can pick it up, it'll actually kind of brighten and dim a little bit as we do that. So if we press our press switch, it'll go into its playback mode. And then it'll play back while we bathe with our sound there, and then it'll go into one of its 3 built-in music tones. And of course our LEDs will not be affected because the LEDs are only monitoring the recording function of it, not its playback function. I'll reset the recording IC here. And you saw how the light came on and off, so yeah, it only monitors this for the recording. So that is how project 384 works. Now we're going to move on to project 385, which is the playback and record with meter. Here, project number 385, the playback and record with meter. And there it is in the book, and here it is on the board. Now, it was pretty much very similar to project 384, but we took all the LEDs out of it and just replaced the side here where it has the microphone with our meter, and that will allow us to see the current on the input side of the recording IC. So if you turn on the slide switch, you notice that the meter deflects to the right, showing about 7-8 milliamps of current flowing through the little circuit here for the input side. And you would figure that if you make noise into the microphone, you'll change that current setting, which of course is what is the audio going into our recording IC. So I'll take something like the motor, and you notice as I was tapping on the microphone there with the motor that the needle of the meter deflected some because it was picking up the audio of me striking this against the microphone there and then storing it in our recording IC, which we should be able to play back. So that is essentially how project number 385 works. Now we're going to move on to project 386, which is the alarm light. So here we are with project 386, the alarm light. There it is in the book, and here it is on the board. And for this we simply have the SCR being triggered by our 5.1K resistor, which is illuminating our 6-volt lamp. And we usually have a little jumper wire here, so I'm just using our little 2.5-volt lamp here as the shunt there to keep the SCR from turning on. So we power on the circuit. Obviously nothing happens because the current is just flowing through our resistor and our 2.5-volt lamp back to ground here. But as soon as we break that link, it sends the power to the gate of our SCR and turns on the SCR, allowing our 6-volt lamp to light up. And regardless if we take the current away from the base there, because the SCR is triggered, the lamp will always stay on regardless of how many times the SCR gets triggered till we reset the power, in which case it won't come on again till we break that link. So that is how project 386 works. Now project 387 is alarm light 2. So here we are with project 387, alarm light 2. There it is in the book, and here it is on the board. And again, just using a number 4 snap wire instead of our jumper wire here, but again, we still got 6 volts. And we're using our SCR to trigger our 6-volt lamp, but this time it's also getting triggered via our NPN transistor, which is feeding its gate. Now you see that the variable resistor here, this actually serves no point, it's just a fixed value that's providing resistance to the base of our NPN transistor there. So when we turn on the circuit, obviously the lamp doesn't light because the SCR is not triggered, nor is the NPN transistor being triggered because we are grounding out the base of it through our variable resistor here. Now as soon as, of course, we take this 4-snap wire away, enough current goes into the base of the NPN transistor, turn that on, which then allows current to go into the gate of our SCR, which turns that on and turns on our 6-volt lamp. And again, even if we disable power to the NPN transistor there by shorting its base again, since the SCR is already turned on, the lamp stays on as long as current's flowing through it. So turn it off and back on. Again, it's reset, take it away, turns back on again. So that is project number 387. So now we're going to move on to project 388, which is the night police car. So this is project number 392, the daytime light police car. There it is in the book, and here it is on the board. So with this, we're again making use of our SCR, which is feeding our alarm IC, and we're controlling it with our photoresistor. Now the way that this works is that we actually want the IC to turn on when there's no light coming into the photoresistor, because when we have light coming into the photoresistor, we're actually taking power away from the SCR, which doesn't allow it to trigger, thus allowing any sound to be generated from our alarm IC. So I'll use my little UV light and place it over here. And when we turn on the circuit, well, no sound comes from the alarm IC because the resistance through the photoresistor right now is quite low. So it's just discharging through our 10,000 ohm resistor to ground, not allowing any current to go to our alarm IC. Now, when we get the resistance high on the photoresistor by covering it up, now we get sound from our alarm IC, because now it allows the SCR to trigger and get current through there. And as soon as we bring the light back, it diverts current away, doesn't allow the alarm IC to come on. So that is how project number 392 works. Now project 393 is the daytime light machine gun. And so what we're going to do with this is just connect points B and C. They're a little short right there, like so. And so we'll do the project over again. Then we turn the circuit on again, no power goes through our SCR. As soon as it gets dark, it now generates a kind of electronic machine gun sound, because we've now connected points B and C together. And we can bring our light back, turn the circuit back off. So that's how project number 393 works. Now project 394 has us connect points A and B. So connect that together here. And it says it's supposed to give us a fire engine sound. Interestingly, it's doing absolutely nothing. Interesting. That is how the project wants us to do it. Yet it doesn't seem to be working. Supposed typo in there. Again, as I say, that part of the alarm IC, this still hasn't been replaced. I don't know if that has anything to do with it or not. If it's shorting the ground straight through there or not. So, can't really show Project 394 from that. So with Project 395, it's now the daytime light ambulance. Now that one, we connect points A down to here, down to ground, and with that, it gives us an ambulance sound. Oops, knock that over. So turn the circuit on, again nothing happens, we take the light away, and now we get an ambulance sound being generated out of the alarm IC because we connected these points together. And bring the light back in, and it turns our SCR off. So that is project number 395. Now we're going to move on to project 392. Yeah, 391 was the night ambulance, and 392 is the daytime light police car. So here, project 392, the daytime light police car. There it is in the book, and here it is on the board. And basically, it's just the opposite of what we did with project number 388, because now instead of needing to have nighttime in order for the IC to trigger, now we need light for it to trigger, because we've moved the photoresistor up to this point for triggering the SCR and put the resistor down here. So if we have our photoresistor covered up, if we turn on the circuit, this time nothing happens because we don't have enough current going through here to trigger our SCR. As soon as we let light in, we get our alarm IC to trigger there. And actually, I realized part of the reason that it's behaving like this is because we've actually got too much resistance here taking the current away. It's actually supposed to be the 100,000 ohm resistor here and not the 10,000, because we're actually losing some current through there. So we turn it on. Now it behaves like it should because we're not losing all that current there. And again, it will stay on because it's an SCR, but start with it closed up, let it come on. As soon as light gets in, the SCR triggers, and in this setup it will stay triggered regardless if we cover it up again. So that is project 392. Now 393 is the daytime light machine gun. So with that, we're connecting points B and C together, just like we did before. We turn our circuit on and keep our light sensor covered. Circuit doesn't come on as soon as we let the light in. And now it gives us that electronic machine gun sound. And in the case of this setup, we can actually divert enough away from there to actually cut it off. So that's project 393. Now I'm going to skip project 394 because that's the same setup of connecting these 2 points, which, as we found out previously, does not seem to work on this alarm IC, so we're skipping project 394. Project named 395 is the daytime light ambulance. So like before, we connect those 2 points there, turn on the circuit. Again, nothing happens with the light sensor covered up. Let the light in, and it generates our ambulance sound. And this setup doesn't allow the SCR to turn off, just like 392. So that is project number 395. So now we're going to go to project 396, which is the flashing 8. So here we are with project number 396, the flashing 8. There it is in the book, and here it is on the board. And this circuit is relatively simple, despite the fact that it's got a whole bunch of snap connectors on it. We've got our 7-segment LED display, and all the segments are lit up except for our decimal point. Using 3 volts, everything's being limited by a 100 ohm resistor, and it's feeding our alarm IC, which its output is then fed to our 7-segment LED. So this is making the electronic machine gun sound, and because of that, every time it sends a signal out through here, it illuminates the segments on our display, and of course it will flash. So we turn it on, and we get our number 8, and as we see there, it's flashing every time the alarm IC is putting out a signal like that. And so that's basically how project 396 works. Now project 397 is the same thing, but we take our speaker and we connect it across G and our 3 volts here. And so now we can hear that electronic machine gun sound, and we still get our flashing 8, although it's not as bright as before when we have our speaker on there, because the speaker is taking most of the current away from the LED. So that is how project number 397 works. So now we're going to move on to project 398, which is the musical space war. So here we are with project number 398, the musical space war. And there it is in the book, and here it is on the board. And so here we've got our 6-volt setup, again using the AC adapter, so we've got a 5 here instead of our 2 battery boxes. The whole circuit's turned on and off via our slide switch. And we've got 2 separate sound systems here, but they use the speaker as a common output. So the first one we've got is our Space War IC, which we can turn on or off and also change the sounds via covering up and letting light in through our photoresistor. And its output is going to be visually seen both through our 6-volt lamp, and then the audio is going to be fed out to our speaker. And then on the other side here, we have our red LED, which is feeding the power to our recording IC, which its output goes to our NPN transistor, which that turns on and off based on the output of the recording IC, which then we can hear through our speaker. And then we have our press switches, which is used to activate the 3 built-in songs and any recordings that are stored on the recording IC. And our antenna here is just acting as a 3-snap wire to provide a ground connection for our recording IC. So if I have this covered up, if I turn the circuit on, we get no sound because we're not allowing any current to go through our Space War IC. So if I let it up, it comes up. And I can change the sound like that. You can see our light is on and our speaker's lit up. Of course, change the audio, and then I can come over here and I can activate the built-in songs to the recording IC. You see our red LED lights up because the recording IC's got power playing through it, and we hear it through a speaker. And then, of course, we can mix the 2 audio sounds together. And you might notice that the Space War IC gets a little quieter while the recording IC is on, and that's also evident from our lamp there, because, and the same thing if I turn the Space War IC off, the recording IC gets louder because they're sharing a common path through the speaker here. So they can't provide as much current through each of them if one or the other is playing while again, one or the other is on at the same time. So if both are on, it only allows so much through. So that's how project number 398 works. And now we're going to move on to project 399, which is the Electronic Noisemaker. So here we are with project number 399, the Electronic Noisemaker. There it is in the book, and here it is on the board. So we've got our 6-volt setup. I just shortened it with the switch here. And we got our NPN transistor, along with our variable resistor here, along with our 10,000 ohm resistor and 5.1K resistor, and combined with our transformer, we're creating an oscillating circuit. And so this will be determined by primarily by our 10,000 ohm resistor, and then we get our two capacitors, our 0.02 microfarad and 0.1 microfarad. The 0.2 microfarad is going to be in the whole circuit, and then we can introduce the 0.1 microfarad by using the press switch. So when we turn on the slide switch, the circuit begins oscillating, and we hear the frequency coming out of the speaker there connected to our transformer. And by adjusting our variable resistor, we can increase the frequency of that sound up to a certain point where it cuts off. And now if we introduce our 0.1 microfarad capacitor, we'll increase the capacitance here because it's in parallel, and that will lower the frequency coming out of the speaker, and we can still adjust it with our variable resistor. So that's how Project 399 works. Now Project 400 is the Electronic Noisemaker 2, and with that we're changing out our 10,000 ohm resistor and instead putting in the 100,000 ohm resistor R5, and by doing that we change the oscillation characteristics of the circuit and thereby the frequency of the sound generated out of the speaker. So if we turn the circuit on now, you hear the frequency is different because the oscillation is different with this much higher resistance there. We've increased it by a factor of 10 because we had 10,000, now we have 100,000 ohms there. And you see our frequency is actually a lot lower this time than the previous project. So that's how Project 400 works, and now we're going to look at Project 401, the B. So here we are with Project 401, the B, and there it is in the book, and here it is on the board. And it looks very similar to Project 399, although in the book it's a little different because I just kind of tried to reuse what was already left over from Project 399 instead of rerouting everything. So even though it looks a little different, the circuit still behaves in the same manner. So we've taken away stuff like our variable resistor and our two capacitors in parallel with the press switch, so instead we now have the capacitor and press switch over here, a 100 microfarad capacitor with our press switch, because this will charge up the capacitor and then it will continue discharging through the NPN transistor here, which will keep the circuit active after the press switch is let go, and that will kind of start with the sound off high and then kind of ramp its way down till it completely discharges. So by pressing press switch, you can kind of hear the oscillation occurring there with the frequency of the sound. And I may even bring the camera in here so you can hear that next to the speaker. And when I let off the press switch, you can see the sound kind of fade away there, and it restarts when I press the press switch and let off again. And you can modify this circuit in certain manners. We can take off our 0.02 microfarad and replace it with the 0.1, and by increasing the capacitance we can lower the tone in the output there. So do it again. Now it sounds lower, and as before the sound fades out when we let off the press switch. We can increase this capacitance even more and put our 10 microfarad on there. And positive is this way because our 6 volts is coming in through that direction. Now with the 10 microfarad capacitor, because there's so much capacitance, it just clicks. We don't get a continuous tone out of it. And when we let off the press switch, the clicks slow down again as our 100 microfarad capacitor running the NPN transistor discharges. So that's basically it for Project 401. Now Project 402 is B2, or B number 2. So what we're going to do is take our capacitor off and put our 0.02 microfarad back into the circuit. But here we're going to remove our speaker, and we're going to put our whistle chip across these points. So the transformer is not being utilized. We're just going to have the whistle chip across there. And then we're going to see how it listens this time. So it's actually much more audible with the whistle chip. And like before, it fades out. And again, we can do the same thing with changing our capacitors out. So we'll put our 0.1 microfarad capacitor back. And again, the tone is lower, where it fades out. And then, of course, we can go up to our 10 microfarad where it clicks. And see, it's a very distinct sound from the whistle chip versus going through the transformer on our speaker. So there's project 402. Now project 403, let me put this capacitor back. And we'll just leave the whistle chip for there because it's optional to have the whistle chip or the speaker for project 403. So it's just B3. Because you know we have, like I say, B2, B3. And with that, what we're going to do is simply change our capacitor here, which determines how long the oscillation in the circuit goes on for. So instead of 100 microfarad, we're going to replace it with the 470 microfarad. And as you can probably guess, by increasing the capacitance there, we'll make the oscillation last longer in the circuit so that it will stay going for a longer duration. Then we can bring our camera down near the whistle chip. So I'm pressing and holding the press switch. I'm going to let go. And you can tell that the whistle chip is still decaying down over time, but it's taking much more time for that capacitor to completely discharge through the transistor. And of course we can still play around with the other capacitor for how the oscillation is. It almost sounds like a roulette wheel, or like Wheel of Fortune with a little ticker going by. But anyway, that's how project number 403 works. And camera in right focus here. So now we're going to move on to project 404, which is Oscillator Sound. So here we have project 404, Oscillator Sound. There it is in the book, and here it is on the board. It is a little slightly different because, again, I'm accommodating for the DC adapter there. But again, we've got our NPN transistor with our transformer outputting to our speaker, and then our C2 and C1 capacitors coupled together there to help create the oscillation. So this helps with oscillation, and on our bass helps control the tone. And we got our R5 100,000 ohm resistor to help limit current. And we have a little red LED, which pretty much just illuminates as long as the circuit is turned on and there's power going through. So we turn the switch on, our LED lights up, and our speaker is emitting a tone. Let me bring the speaker or camera down, loudspeaker. So you can hear that it's emitting a tone because that, again, the circuit is oscillating, and we're picking up the AC voltage that's being generated through the transformer as audio out of our speaker. Now, that's how project 404 works. Now project 405, we're going to change the tone by adding more capacitance. So we're just going to simply take our whistle chip and put it on top of capacitor C1 and bring it down over there by the whistle chip. So now you hear more of the audio from the whistle chip, but it's a lower tone now because the whistle chip is adding additional capacitance in parallel with the C1 capacitor, the 0.02 microfarad one. And by doing that, we get a lower tone being generated. Back over this way. So that's project number 405. Now project 406. we go back to as before, but now we're going to change the whistle chip in parallel with capacitor C2. So we had it in C1 for the previous project, now we're going to put it across C2. And now we get an even lower tone because now we're putting it in parallel with an even higher capacitor, the 0.1 microfarad. So by doing that, increasing the capacitance, we generate an even lower tone than the previous two projects. So that's project number 406. Now project 407, again going back to the previous setup. And now this time we're going to take our 10 microfarad capacitor here and we're going to put it over top of resistor number 5. So we're going to put it in again in parallel with C1 there on top of our resistor. And here now the circuit has such a delay in its oscillation that it's actually clicking, and we can both hear and visually see that because our red LED is flashing, and bring the camera by our speaker, you may just hear it clicking. And so by adding that much additional capacitance to the circuit, the oscillation is now at the point where it just clicks on and off instead of producing a constant tone. So that is how project number 407 works. So now with project 408, what we're going to do is we're going to change out our R5 resistor for the photoresistor. So I'm going to take this out here, and then by using the photoresistor we can create variable resistance depending how much light enters our photoresistor here, and be able to change the oscillation of the circuit that way. So turn it on. See, by changing the light coming in, you can see that the brightness of our red LED changes, and also the audio coming out of our speaker changes. And if I put more light on there, see, now the circuit's not oscillating at all, but our LED is nice and bright. Take the light away and it starts getting oscillation again. So I'm waving my hand across the photoresistor there, changing the oscillation of the circuit. So that is how project number 408 works, and that concludes this set of Snap Circuits videos.